Let's talk about an interesting topic: placement groups. Imagine you are launching multiple EC2 instances. How will AWS deploy these instances on the underlying hardware? Will all instances share the same underlying hardware, or will the instances be spread across different underlying hardware? By default, when you launch EC2 instances, you have no control over how AWS deploys them to the underlying hardware, but you can influence this using placement groups. Placement groups allow you to influence the placement of instances on the underlying hardware. This can be useful for use cases such as achieving low latency or reducing the likelihood of failures. For example, you may want to pack your instances close together to achieve low latency or distribute them across different underlying hardware to reduce the probability of failure. By default, the EC2 service tries to place the instances so that they are spread across the underlying hardware. But as you can imagine, this is not always the ideal scenario, especially if you are trying to bundle them together to achieve low latency. Therefore, there are three types of placement groups: clustering, partitioning, and spreading. A cluster placement group, then, is a logical grouping of instances in a single availability zone. All instances in a cluster placement group have access to a high-performance, high-bandwidth network segment, and for this reason, a cluster placement group is ideal for low-latency, high-performance applications. For example, high-performance computing or HPC applications that need to process data and perform computations at high speed. Clustered placement groups are also recommended when most of the traffic occurs between cluster instances, since all instances in a clustered placement group are in a single availability zone. It is important to note that cluster placement groups are not compatible with bursty performance instances, such as T2 and T3 instances. Then, there are the partition placement groups. With partition placement groups, instances are grouped into partitions and each partition is housed in a separate rack. Each rack has its own network and power supply, and no two partitions in a placement group share the same rack. Since the instances are housed in separate partitions, the likelihood of correlated hardware failures is reduced. It is important to note that partitions can be spread across multiple availability zones in the same region, and that you can have a maximum of 7 partitions per availability zone. Partition placement groups are ideal for deploying large distributed workloads, such as Hadoop, Cassandra, and Kafka, in different racks. And finally, there are spread placement groups. With a spread placement group, each instance is placed on different underlying hardware. So, the difference between partition placement groups and spread placement groups is that with a partition placement group, a group of instances share the same partition and no two partitions share the same rack. But with spread placement groups, each instance is in a different rack. Each rack has its own network and power supply and reduces the risk of simultaneous failure that would occur if instances shared the same hardware. Spread placement groups are ideal for critical applications where instances must be isolated from each other. Some other key points about placement groups are that there is no charge for their creation. They also cannot be merged, and an EC2 instance can only belong to one placement group. So, with this in mind, let's go to the EC2 console and configure the placement groups. Well, before you can launch an EC2 instance in a placement group, you must first configure it. To do that, from the left navigation pane, we go into Placement Group and Create. Here we can see the three types we have talked about: cluster, spread, and partition. Let's create a placement group of each type, starting with the cluster placement group. I'll call it Cluster PG. I set the type as cluster and create. I will repeat the same for the remaining two types. Let's call it spread PG. And the type is spread. Now, notice that I can choose the type of spread, also known as spread level. Normally, you'll use rack. However, if you use AWS Outposts, you can also set it up as a host. AWS Outposts allows you to bring AWS services to your own premises environment or your data center. For this example, we'll set it to rack and click Create Group, and we'll repeat this same thing for the partition placement group. I'm going to call this as partition PG, and set the partition type. When you're creating a partition placement group, you can define the number of partitions you'd like to create. I'm going to set it to 4 and click Create Group. Now that we have the placement groups, we can launch EC2 instances on them. Let's try to do that. I'll go to Instances in the left navigation pane and launch Instances. I'll select an army, an instance type, provide a key pair. I'll select an existing security group. Then I'll scroll down to Advanced Details, where I can set the placement group. Here we can see the 3 placement groups that we've created. Then, when you select the partition placement group, you can also select the partition on which you want to launch the instance. For example, I can see all 4 partitions. In this case, I will select partition 2. So, with a partition placement group, you have visibility of the partition on which the instance will be launched. Once the necessary items are configured, we click on Launch Instance. View all instances, and if I select that instance, the details of the placement group can be seen here at the bottom of the screen on the right-hand side. Here is the placement group ID and the partition number on which the instance has been launched. So, as we've seen, placement groups can be very useful in influencing how AWS deploys instances to the underlying hardware.